Okay, assuming a constant pressure, by what approximate ratio does the balloon shown on the diagram expand when the gases it contains are heated from 25 degrees Celsius to 125 degrees Celsius? Now I chose this question because it's a typical ideal gas law question where you have a before scenario, the 25 degrees Celsius temperature, and an after scenario, you're taking it to 125, and you're trying to see what happens to the volume. By what approximate ratio does the balloon expand? So it's a volume question. But nevertheless, this question does involve our ideal gas law. Let's write it down. Now, in your chemistry class, you might call this a Charles law question, where it's a volume-temperature relationship. But in physics, we don't really necessarily like to memorize all that stuff. We have one equation that works for all ideal gases. So all we've got to do is figure out what's constant and what's not constant. What are our variables in this question? So our constants, well, it says the pressure is constant. So I'm going to circle all our constants. Pressure, the number of moles, and the ideal gas constant obviously never changes. So what we're left with is V and T as our variables. So if I get all my variables to one side of the equation and all my constants to the other, I get a formula that looks like this. Dividing both sides by T, I get V over T, and putting all my constants on the right, or leaving them on the right, NR over P. So I get volume divided by temperature. That ratio is a constant. So here's what we're saying. For this particular question, my volume divided by my temperature is a constant value. Now what that means in terms of our before and after scenario is that my initial volume and my initial temperature, that ratio has to stay constant. So it has to equal my final volume and my final temperature. And this little equation that I'm going to put a box around is the one we're going to use. So all I have to do now is put in the values. So we're going to try and see what happens to our volume. We have to remember with ideal gases, we cannot use temperatures in degrees Celsius. They must be Kelvin. So let's convert first. So T1 is 25 degrees Celsius. And if I want to convert that to Kelvin, I simply add 273. So 273 plus 25 gives me my Kelvin temperature of 298. And similarly, when I add 273 to 125 degrees Celsius, I will get 398 Kelvin. So those are our two temperatures that we're going to plug into our formula. So now we get a ratio that looks like this. V1 over 298 equals V2 over 398. A little bit of cross multiplying because we want to see what the new volume is, what it expands to. So I'm going to solve it for V2. V2 would be 398 Kelvin all over 298 Kelvin all times V1. Or if we convert that to a decimal, we get 1.33 V1. So about 4/3 V1. The volume has increased by 4/3. So our ratio's got to be B 4 to 3. That's our best answer.